Now we're going to take a look at section 2.5 concavity. First point we'd like to make is that the graph of a linear function we know is a straight line because the average rate of change is a constant. So for example, if I take a look at a line and I happen to make a table of something that's linear, I have x being 0, 1, 2, and 3, and y being 2, 5, 8, and 11, and it's fairly clear, I think, that the slope is always going to be 3. I did a number of the computations out. I did 0 to 1, 1 to 2, 2 to 3. They all come out to give me a slope that's equal to 3. So we notice the average rate of change is always the constant number 3. Since the average rate of change is the same on all intervals, we know we have a line. However, we know not all graphs are straight lines. They may either bend up or bend down, or in some places bend up and in other places bend down. Let's take a look at an example. Here I have a table where I'm going to use the x's are 0, 1, 2, and 3, and my y's are going to be 2, 5, 12, and 23. If I now compute the same slopes, the slopes from 0 to 1, 1 to 2, and 2 to 3, you will notice when I do the math, I end up getting the slope from 0 to 1 is 3, the slope from 1 to 2 is 7, and the slope from 2 to 3 is 11. Notice when I graph those particular points and I connect the dots, I get a graph that appears to have a kind of a curve up. The graph we know has an increasing slope. When we have a function that has an increasing slope, or in a region where a function has an increasing slope, we call this concave up. So if x increases and the average rate of change increases, then we are going to say we have something that is concave up. And things that are concave up, or parts of graphs that are concave up, will often look like the graph that we have drawn on the screen right here. Let's take a look at the second table. Again, 0, 1, 2, and 3, and this time the y's will be 2, 8, 12, and 13. And now if I take a look at the slopes, what I notice is my slopes will actually decrease. If I go from 0 to 1, my slope is 6. When I go from 1 to 2, my slope is 4. When I go from 2 to 3, my slope is 1. And so the slopes this time are decreasing. Notice if I graph these points, I get kind of a bending down shape. And the graph of the slope has a decreasing, the graph of the function has a decreasing slope. When this happens, when our slopes decrease, we have a function that we would say is concave down. Or in other words, we would be concave down if as the x increases, the average rate of change decreases. So we're concave up if our slopes or our average rates of change increase. We're concave down if our slopes or our average rate of change decrease. You might ask about the line that we started with. Lines are neither concave up nor concave down.